All right, so pre-calculus 30, we're talking about transformations of rational functions. So I just want to show you real quick, just on Desmos here, how the parameters change the look of the graph, how they stretch, how they move the graph, and so on. So what I have here is, right now, I have y equals 1 over x. That's it. Because a is 1, b is 1, h is 0, and k is 0. So really this is the same as 1 over x. So if we zoom in here, okay, this is what this function looks like. Okay, as x gets larger from 0, as it gets larger, you can kind of see that 1 over x, right? It'll be 1 over 1. So at x equals 1, we have 1, 1. 1 over 1 is 1. 1 over 2 is 1/2. 1 over 4 is 1/4, and so on. So 1 over 6, 1 over 10, 1 over 1,000. You can kind of see that the graph gets closer and closer to what? 0. So the horizontal asymptote for 1 over x is
0.
Y equals 0. Very good. Okay, and that makes sense because the degree of the numerator is smaller than the degree of the denominator, right? That's always y equals 0. Okay, so what happens if we change the parameter of a? Okay, so what does a usually represent? It represents a vertical stretch, right? Not a vertical translation, but you corrected yourself right away. Good. Vertical stretch. So it actually pulls it up and down away from the x-axis, right? So let's see. If I move 1 up, okay. Now it looks like it's going out on an angle, but really it's being pulled up. And what I might do here is, let me just adjust this. Let's make this just a 1 over x, and I'll just light that up too. So the black is 1 over x. And so here we go. This is 1 over x. And as a gets larger, it sort of pulls down and pulls up, it stretches. Okay, does that make sense? Okay. So it's a stretch. It's a stretch vertical. Okay. Well, that makes perfect sense. What about b? Now remember, in a rational function, 1 over x, the b value is down here with the x, and so is the h value. Very important. It's all attached to the x value. So it's got to be in the denominator here. So what normally happens with b? As b gets larger, what happens to a function? Does it stretch out if b is large, or does it compress in if b is large?
Oh, if b is larger,
if it's greater than 1, it's, yeah, because the stretch factor is 1 over b. So if b gets larger, then it kind of squishes in. So let's see. Let's just drag this cursor. Okay, I'm making b larger, so there you go. It's pulling in towards the x-axis there. See that? Okay, so it's literally squishing up this way. See that? Okay. Okay, so that's great. Now what about h? What does h normally do when we're talking about transformations of functions? Yeah, it shifts left and right, okay? So let's see. Now it's x minus h, right? So as h gets larger, that's x minus 2, x minus 4, x minus 10. It's going to move it which way? To the right. As h gets larger, really it moves it to the right, but it shows up as a minus in here, right? So this right now would be x minus 2.2, which means it's 2.2 to the right. So it's just opposite of the sign that's in there. So as h gets larger, okay, it moves to the right, which shows up in the equation as x minus, in this case, 8.2. Okay? So as x gets smaller, it moves to the left. H gets larger, moves to the right. Okay? So that's your horizontal shift. Good. So we'll put that back to 0. And k is the vertical shift, or vertical translation. Okay? So that is still true. Okay? So it moves up, it moves down. All right? So we can let all these go together and watch. We'll have a real. So you can kind of see that's the k. Here's the h moving left and right. Okay. Here's the b getting large, so it squishes in and then it pulls out. Oh, and when b gets negative, it flips, right? Cool. Okay. And then a stretches up, and what happens when it gets negative? Ooh, flips around.
What happens if you let A and B move at the same time?
If you let A and B move at the same time,
when they're both negative, they should flip, you know. Flip.
So they're kind of counteracting each other a little bit there. They balance each other off. Let me just. There you go. Cool. Move H and K around. Woo! That's strangely satisfying to me. It's just like it's like watching fish swim. Oh.
I love watching fish.
Yeah, see? I know, I'm saying it's like watching fish swim. It's so peaceful. Like, I love it. It's great. All right, so any questions about transformations of rational functions there? Oh, I stopped it at a equals 0. Look at that. If a equals 0, look at that. A equals 0, we just have a flat, straight line. Look at that. So there you go. Okay, there you go.